Okay, everyone, this should be recording now. So this is a repeat of lesson 1 that we did yesterday. We had some recording issues the other day, so we're going to start this again for today. I don't have my camera on because I was having some technical confusion, so I'm just going to do this so that you guys can see the whiteboard and see what I'm doing as I talk. I think it's going to be the most useful anyways. So this is a crash course, as you all know, for the math you need for your carpentry program. We want to start today with something that should be relatively familiar to all of us, and that is fractions. Fractions are just ways of representing numbers, and typically we use fractions to represent numbers between 0 and 1. The only thing I really want to point out on this first sort of slide here is that there are more than one way to write the same number. In this example, 1/4 is exactly the same as 2/8. And we can simplify those. We see that 2 is exactly twice of 1, and 8 is also exactly twice of 1. So if we multiply both the top and bottom number of any fraction by the same number, that number actually represents the same thing despite appearing different. In this slightly more extreme example, 1/2 is equal to 2/4 is equal to 3/6 and 4/8, and so on. So why do we use fractions instead of numbers? We use fractions instead of numbers because they're more exact. Take, for example, 1/3. If I was to write this as a decimal number, this would be equal to 0.33 ... We can also write that as 0.33 repeating. This horizontal line on top of the number means that repeats forever. So if we were to type this into a calculator, we couldn't actually put 100% accurate value. Whereas if we type in 1/3 in a calculator, then we actually get an exact value, and the calculator can carry through that exact value so we don't get errors. Have to remember to erase when I scroll down. So fractions are numbers just like any other, and we can do operations with them. By operations, I mean things like multiplication, division, addition, and subtraction. I think that the easiest of these when it comes to working with fractions is multiplication. So we're going to start with that. So in this first example, 2/3 times 1/4. The nice thing about working with fractions and multiplication is that it's just like normal numbers, and we work top to top and bottom to bottom. So we do the top first. 2 times 1 is equal to 2. Anything times 1 is equal to itself. And the bottom, 3 times 4 is equal to 12. So we could be done here. This is a correct answer that represents the exact value that we wanted to get. However, we can write this in what we call simplest terms. 2 is divisible by 2, and 12 is also divisible by 2. So we should do that division to both the top and the bottom. 2 and divide 2 gives us 1/6. 1/6 would be our final answer. Now, it's not incorrect not to do the simplification, but we do it so that it's easier for an end user to recognize. For example, if I said I need a 1 9/12 of an inch cut on a piece of wood, that's kind of confusing and takes a minute for you to process and understand. But much easier would be if I said I need 1 3/4 of an inch cut on this piece of lumber. Let's do one more. So we have 8 divided by 3 times 2 divided by 7. Again, we work on the tops, separate from the bottom. So 8 times 2 is 16. Divide 3 times 7, that's 27. Now, here we have to check again if this is lowest terms, and we do that by looking for a common factor between these numbers. So 16 can divide by 1, 16, and 4. And 27, luckily for us, does not divide by 1, 16, or 4. So this means this cannot be simplified any further than it already is, because these two numbers do not share a common factor, so we cannot divide both by the same value and get whole numbers out of this. One more is 1/5 multiplied by 7 over 15. Again, top to top, bottom to bottom. You can write this as 1 times 7 divided by 5 times 15. 7 times 1 is equal to 7. 5 times 15 is 75. And 7 is a prime number, so all we have to do is check if 75 can be divided by 7. In this case, it cannot. We can use a calculator to do that. I am actually going to pull up my calculator app on this computer because there we go. Whoa, that's big. Okay, bear with me just a moment. I just want to make this a bit smaller for us so we can keep it off to the side. So we can double check, say 7 divided by 75. We do not get a whole number, so we can see that this is not divide out. So we can move on to the next operation of fractions, which is division. Now, as I said earlier, I find multiplication to be the easiest thing to do with fractions, but dividing is not that bad. Dividing is nice because we can change it into a multiplication to make our lives easier. Now, in order to do this, we have to think about what are multiplication and division relative to one another. And multiplication and division are what we call inverse functions. They undo each other. And we have the same concept in fractions. We have something called an inverse fraction. An inverse fraction is a fraction turned upside down on its head. So when we want to divide a fraction, we leave the first thing, the thing we are going to divide, the same. In this case, 2/3 stays the same. We then take the second thing, the thing we are dividing by, in this case 1/2, and we flip it on its head, 2/1. Now, because we have flipped the second fraction, the thing we are dividing by on its head, we get to switch that division for a multiplication. And now this is just like the problems we were doing before. So we go straight across, 2 times 2, 4, 3 times 1 is 3. 4/3 is a final answer because 4 cannot be divided by 3. It's a prime number. So moving forward, we have 4/3 divided by 2/5. Again, we leave the first number the same. 4/3 stays just how it is. And we flip the second number, the number we're dividing by, on its head. 5/2. Now we get to swap the division for a multiplication. Go straight across. 4 times 5 is 20. And 3 times 2 is 6. We could be done here, but this is not in simplest terms, and therefore is not easy for an end user, someone you're explaining what your math means to understand. We can divide 20 and 6 both by 2 equals 10/3. Now you'll notice the common theme with some of these examples that they are all turning into what we call improper fractions. Fractions with a number bigger on top than the number on the bottom. These are annoying and hard to read, but we will talk about that a bit more further on. Right now, I just want to leave everything as whatever fraction we get it, improper or not. So let's do this last example for division. Again, first number, the number we are going to divide, stays the same. 1/5 gets divided by 7/12. So we flip 7/12 on its head, getting 12/7. As we flip this number we're dividing by, we get to change the division for a multiplication, and we go straight across, just like before. This is all equal to 12/5 times 7. 5 times 7. I can pull up my calculator. So 5 times 7 is 35. Let's just confirm. 5 times 7, 35. So we got 12/35. Now we have to decide, is there a common factor? Factors of 12 are 1 and 12. Neither of those divide 35. We have 3 and 4. Again, neither of those divide 35. If we need to, we can check. Pull up the calculator. We go 35 divide 3. That's equal to a not whole number. Therefore, we can't use that. Or 35 divide 4. Again, a not whole number. Therefore, we cannot say they divide to simplify fractions. So this is fully simplified. We get to move on. So I hope that this is making sense, how we can change divisions into multiplications, and I also hope that multiplication, where it goes straight across on the top, is working out for you. As we move forward, we're going to get to functions with addition and subtraction just in a moment, and they are a little more cumbersome and are going to take a little bit more time, but we can do it anyway. So adding and subtracting, these we treat exactly the same. We don't have to worry about differences between adding and subtracting because we treat them identically. The hard part with adding and subtracting is that we have to be very good at representing the same fractions in different ways, because what we need to do addition and subtraction with fractions is a common denominator. The denominator is the number on the bottom of the fraction. In the case of 1/2, the denominator is 2. In the case of 1/4, the denominator is 4. Okay, so what we hope when we are adding and subtracting fractions is that one denominator can be multiplied by a number and then equal the other. So in this example, we're lucky. 2 can be multiplied by 2 to get 4. So we leave the 1/4 alone because we can make the other fraction's denominator match it. So when we are adding, the addition or subtraction, whatever it is, stays exactly the same. And we said we had to multiply by 2. So we have to multiply the top and the bottom. Otherwise, we will be changing the fraction's value. So 1 times 2 is 2, and 2 times 2 is 4. All of this, once we have common denominators, becomes very easy. So bottom number is common, it stays the same. We do not change it. Once we have a common denominator for addition and subtraction, it will not change for the rest of our equation. And 1 plus 2 on the top, we just add them like normal. 1 plus 2 is equal to 3. 3/4 is our final answer for this question. Now I know I'm moving fast. Because I'm just recording this without anyone watching live, I want to just work through it at a speed that is normal for me, and know that you guys have the access to pause and rewind functions, so that if you need to see anything again or have it re-explained, feel free to pause, rewind. There will also be a link with a practice problem sheet posted to go with this lesson. Please, if you're finding this a little fast-paced or a little confusing, please take some time to go through those questions and make sure to contact me with any questions you might have, and we can cover them either in a later lesson or together if you're able to come into the school. Let's do one more example, or 2 more examples with addition and subtraction. So 4/3 subtract 2/5. Now, this first one worked out pretty nice. We were able to multiply easily one of the values to get the other and get our common denominator. In this second question, that's not going to work out so easily, and the reason I say that is because these are both prime numbers. So they are only divisible by 1 in themselves, which means you can't multiply another number by something and get that number. So the easiest option we have here is to take the bottom number from the first fraction and multiply the second fraction by 3/3, and then take the bottom number from the second fraction, in this case 5, and multiply the first fraction by 5/5. I'm going to write that out bigger here. So 4/3. I'm also going to change my color of pen so that I'm not getting distracted with the question above. 4/3 subtract 2/5. I want these to have a common denominator, and the best way to find a common multiple of 2 numbers is just to multiply them together. So I'm going to take the fraction over 3 and multiply it by 5/5, and the fraction over 5 and multiply it by 3/3. This is exactly the same equation as 4 times 5 is 20, and 5 times 3 is 15, minus 2 times 3 is 6, and 3 times 5 is 15. So if you follow what I did there, I took this 3 and I multiplied it by 2 and 5, and then I took this 5 and I multiplied it by 3 and 4. I left all those numbers exactly where they were, and you'll notice that I now have common denominators. if I keep going with this equation, 20 minus 6 is equal to 14. And we have a common denominator, so that is going to remain the same. Just like that, 14 and 15 do not divide by any of the same factors, so this is in simplest terms. One more for the addition and subtraction section. We have 1/6 plus 7 over 2. We sort of have two options. On the first one, we were able to find a factor that we could multiply one side by to make a common factor without changing the other. In the second, we had to change both fractions. Both are equally right and will always work. But in this case, I can't help but notice that 6 is exactly half of 12. So if I multiply this by 2, I'm going to get the common denominator of 12, and I don't have to touch my second fraction, which is great. It makes my life a few steps easier. So 1/6 times 2 over 2 is 2 over 12, and we add 7 over 12. That's exactly how it was. Recognize that 2 over 12 is exactly the same as 1/6, so we have not changed the value of this problem. Continuing on, we have 12 as the common denominator. That is going to remain the common denominator, and 2 plus 7 is 9. We're almost done here, but in this case, we can simplify. 3 is a factor of 9 and a factor of 12. If we divide 9 by 3, we're going to get 3. And if we divide 12 by 3, we're going to get 4. 3/4 is our final answer. Again, I hope you're following this. I know I'm moving quite quickly today, but that's just because I don't have any students live here with me. Please take your time, pause as you need to, and think about these, as well as take your time to do some of the practice questions, as many as you need to feel comfortable, and ask any questions you might have. So I want to talk finally, well, not finally, but for the end of this section, I want to talk about different ways of representing fractions. We have improper fractions, mixed numbers, and decimals. Decimals are what we're used to. They're just numbers. 1.7, 2.3, 4, these are all decimals. Mixed numbers are when we say something like 1.5, 2 3/4. Again, something we're used to saying and we're used to understanding in everyday life. Mixed numbers are hard to work with in math equations. So in math equations, even though they're the hardest to understand, we typically prefer to work with improper fractions. These are things like 19 over 3, 7 over 4. They're weird numbers that aren't intuitive to our minds, but that work out nicer when we're actually proceeding with calculations. So because some of these things are better for calculation and some of them are better for us to understand in conversation, it's very advantageous for us to be able to switch between different types. So let's explore that for just a minute. So 19 over 3, how can we write that as a mixed number? Well, we first have to think about what 19 over 3 is. Remember that 3 over 3, or any number over itself, is equal to 1. So our goal really is to figure out how many 3 over 3s fit in to 19 over 3. So let's do that. Remember, when we're adding fractions, the denominator stays the same as long as it's common throughout all the terms. So we can write 3 over 3 plus 3 over 3. But we would add the tops and the bottoms would stay the same. So that would be 6 over 3. We're not quite there. Plus 3 over 3. Again, we add the tops. This is going to give us 9 over 3. We're still not at 19. I'm sorry. 3 plus 3. Yeah, 3 plus 3 plus 3 is 9. I don't know why I just got confused there. Again, we can add 3 over 3. That is going to give us 12 over 3 plus 3 over 3, 15 over 3 plus 3 over 3, 18 over 3. And how much do we have left? If we need to get 19, we only have 1 left, plus 1/3. So that's 1, 2, 3, 4, 5, 6 ones, and 1/3. So we can write that as 6 and 1/3. There might be an easier way to get this, but I wanted to write that out so you guys can see the process of where this comes from. If you have a calculator on hand, this becomes a little bit easier. Clear. everything in the calculator. 19 divide 3 equals that first number before the decimal point, 6. We've got that right here. That is how many whole 1 values fit into 19 over 3, and there is some amount left. So what I like to do, once I know there's 6 times the bottom number of my fraction, in this case it's 3, is equal to 18. 18, how much more is there to get 19? 1. Put that 1 over the 3 that existed in the improper fraction, and you're done. I hope that between those two, you can kind of start to see where this is all coming from. But we're going to keep going with this example. We're going to go to decimal numbers. So 6 1/3, how do we write that? Well, you saw in the calculator when I typed in 19 divide 3. It's 0.333333. This is, again, part of the reason we like fractions. They are exact, and they do not need to have a rounding error. So 6 1/3 can be written as 6.3333. You can draw a line to say that that repeats forever, but we know we can't type that into a calculator exactly, which is very unfortunate for us, which is why we like to work with fractions. Mixed number again, 1 2/5. So let's go to an improper fraction first. I think that's probably easier. So think of 1 2/5 as being like 1 plus 2 over 5. And then recall how we add fractions. We need a common denominator, and thankfully whole numbers are very easy to get a common denominator with. Multiply the whole number by the denominator you want, and put it over that denominator. In this case, 5 over 5 plus 2 over 5. Remember, when we have a common denominator, we add the tops, and the denominator stays the same, 7 over 5, and that's our final answer for our improper fraction right here. So I will erase this to get it out of our way. And now we have to go from mixed number to a decimal. Whenever I'm thinking about converting fractions and decimals, I always like to get my fraction over 10 or multiple of it. Makes it kind of nice. So in this example, 1 2/5, we can rewrite this as being equal to 1 4 over 10. 4 over 10 is something we sort of have an understanding of because we always work in tens in decimal numbers, right? We divide hundreds into 10 tens and tens into tens ones, and we divide ones into tenths. So this is something we sort of intuitively understand. So we have 1 4/10, which most of us can recognize as 1.4. If we can, again, we pull out our calculator, we clear everything that's in there, and we say 7 divide 5 equals exactly 1.4. Two more examples here before we move on to the next section. We have a decimal number, 0.1. 0.1 again is something we're used to thinking of. Remember when we look at decimal numbers, how we think of their digit values. We have some numbers before a decimal. Those are ones, tens, hundreds, and so on, going that way. And behind the decimal, we have tenths, hundreds, and so on, going this way. So here we only have one decimal point. We are using the tenths place. So this is 1/10. This is a mixed number and an improper fraction because it is a value less than 1. For any value less than 1, the mixed number is exactly the same as the improper fraction because there's no whole number to write out front in the mixed number. One final example of 7 over 5. 5 goes into 7 one time. So we write 1 right out front. What's left over? 7 minus 5 is 2, and we leave it with 5. That's the remainder. As a decimal now. Again, it's nice to write these as over 10, especially when they're a nice multiple like 5. We have 1 2/5. This is equal to 1 4/10, just like last time. So we have 1.4 again. So I'm going to erase this before we go scroll down. Now, really quickly before we end, I want to talk a bit about units and measurement. Units are the things that give our numbers meaning. If someone asks you how long a road is and you say 780, it doesn't mean much to them. Is it 780 kilometers, 780 miles? What is it? Units give numbers meaning, but they also cause us lots of problems when we're doing calculations. This is because there's more than one unit to represent the same thing. We can use feet and inches, or we can use meters and centimeters to represent distances or heights, and this can cause some confusion. Very, very briefly, I want to just look at measurements on a ruler and talk about how metric measurements versus imperial measurements divide their units. So metric measurements are what I think of as fairly intuitive. They take each smallest thing and divide it by 10 to get a thing that is tenths of that size. So between 15 and 14 centimeters, there are 10 millimeters, and each one is denoted on the scale. We're used to seeing this again because decimal numbers work in groups of 10. So this is fairly intuitive for most of us. Imperial, on the other hand, likes to work in fractions. They take whatever the smallest subdivision is, in this case 1 inch, and they first divide that by 1/2. We go 1/2, and then they say, okay, what's a half of a half? So a half of a half is a quarter, and then they say, what's a half of a quarter? And a half of a quarter is an eighth, and they keep going like that. So you'll notice on the imperial measurement scale, all these ticks have different sizes. The smaller the tick, the more times it's been subdivided by a half. I find this a lot more difficult than metric measurement, but this is something you're going to use all the time in carpentry because you have rulers, and that's just become the standard for the industry to use imperial measurements. You're going to have to get very used to reading these types of fractional measurements and understanding them when people convey them to you. So there's about 2.54 centimeters in 1 inch, and we can use this fact to convert between different measurement systems. Here are some facts of 1 inch. As I said just then, is about 2.54 centimeters. 1 foot is about 12 inches. Well, that's exactly 12 inches. And 1 mile is about 1.6 kilometers. Let's use those values to convert the following measurements to given units. So whenever we're converting, it's best to just start by writing the number we want to convert. 650 kilometers. I like to think of this as being over 1. Just leaves it as the same value. Now, what we want to do is multiply by 1 in such a way that we get rid of units. And this sounds really weird, but I think it will make sense after a couple of examples. So we want to convert from kilometers to miles. Notice that I wrote kilometers on the bottom of this fraction and not the top. I did this very intentionally so that the 650 kilometers, when divided by some other number of kilometers, will have kilometers cancel out. What we need to know now is what to write in each of these values for kilometers and miles. Well, we know from above that 1 mile is 1.6 kilometers. So here we are. We have multiplication of fractions. This is equal to 650 kilometers multiplied by 1 mile. And all of that is over 1 multiplied by 1.6 kilometers. Kilometers divided by kilometers is 1. We're left with just units of miles, and all we have to do left is 650 by 1.6 and miles. So we can type this into our calculator, open it up, clear everything there. 650, that one. 650 divide 1.6, this is 406.25. So 406.25 miles. I'm just going to erase this example now because I've taken quite a lot of space and I want to move it up on my board. So anyone who needs to look at this longer can take a minute and pause. Now let's actually skip the second one and do those last two. So 1 mile, 2 meters. Here we need to do more than one step. We don't have a direct conversion from miles to meters, but we start the same way. 1 over 1. We can multiply this by 1 and it will remain the same value. So we know a conversion from kilometers to miles, and kilometers, we know kilo is 1,000. So 1,000 meters are in 1 kilometer. So let's go to kilometers first. We go 1 mile. We want to cancel miles this time, so we're putting it on the bottom of the equation, as 1.6 kilometers. Okay. Now we have units of kilometers because the miles cancel out. How do we go from kilometers to meters? Well, we want to get rid of kilometers, so we divide it on the bottom, and we put meters on top. There are 1,000 meters in 1 kilometer. Kilometers will cancel. We're left with units of meters, which is what we want. But all we have to do is go through the final calculation. So to clear everything, we have 1 mile. We multiply, because it's on the top, by 1.6. And then we multiply again, because it's on the top, by 1,000. This gives us that there are 1,600 meters in 1 mile. Okay, so these unit conversions are not complicated, but they just take some time to kind of wrap your head around. Once you get there, it will become very second nature. I'm going to move on actually from this second last example on this part, because we're going to do more of this in the next section, which is just to say that it is important when we are multiplying fractions or adding, when we are working with any numbers at all, that we have the same units. Think about it if someone asked you to go into a classroom, count how many tables and chairs there were, and then you came back and you told them there was 50 tables and chairs. Well, that person doesn't know if there's 1 table and 49 chairs or 25 chairs and 25 tables. So it'd be more likely to come back and tell them how many chairs there are separate from how many tables there are. This is just something that's intuitive to us. We have to do the same thing with units. For example, 1 mile plus a half kilometer. We did the mile conversion earlier, but let's do it one more time. Let's convert 1 mile. And we can multiply by 1. We have that 1 mile has 1.6 kilometers. And we multiply 1 times 1.6 is just 1.6. So 1.6 kilometers plus 0.5 kilometers. Now that we have the same units, we can just do addition the way we're used to. 1.6 plus 0.5 equals 2.1. Apologies for the noise that's going on outside right now. I might actually call it there because of that. For it in. Thank you for watching. Please let me know if you have any questions, and do give those example questions a try. I just have to stop the recording.